All right, the last tutorial will be Infraworks, LiDAR and Infraworks. So building upon what we did in the first Infraworks tutorial, we're going to do a model of St. Louis. And I'll show you a few more techniques of what you can do with this information. So the first thing I'm going to do, like we did previously, is I'm going to set a bounding box. So in this case, I'll set the bounding box to kind of be within the LiDAR data set that we created already. So I'll just create a bounding box like that. And actually, I'm turning the fill to nothing and just make the outline red. I want to actually have the river in this because I actually want to model the river as well. And the river shapefile only ends to about there in this case, so I'll just leave it like that. So then I'll take that bounding box, convert graphics to features. I'll just save this as bbox STL. Automatically delete graphics after conversion. Okay, so now we're going to use this bounding box to set our new Infraworks model. So in Infraworks, I'm going to create a new model. So click on New. Call this one STL Downtown, for instance. I'll save it on my computer. Model extents. Define model extent. Load extent from file. I'm going to go to the bbox STL. In this case, I'll use the data extents. Actually, I'll use first polygon in this case to show the difference. Click OK. Give that a second to. All right, so Infraworks. So I set up that bounding box there. Just for fun, I'm actually going to bring in that LiDAR raster straight up in here. You can see what you can actually make. It's actually kind of interesting. It's not the most useful image, but it's pretty cool. And actually, for things like flood analysis, it is pretty. It's pretty cool. So let me just show what it looks like. It's this STL Lighter Tip right here. So you see you can bring in TIFF files as rasters. Double click on it to configure it. You see it automatically brought in as a UTM 8315, which is actually the UTM coordinate system for St. Louis. It just kind of figured out what the correct one is already. So I'll just leave it as is and click close and refresh. And what you're going to see is actually kind of a very unique way to model cities, is just literally model the raw elevation data straight up. There's some artifacts in it which makes it kind of imperfect, but nonetheless it's still pretty cool in my opinion. So this is like when I mentioned, this is just pure elevation data. You can see the arch didn't quite model correctly. The problem with this data set is it wants to create a continuous surface, so it doesn't understand that the arch is like an arc. So it wants to kind of like resolve the high point to a low point, to a high point to a low point like that. So it's just making this horrid looking mohawk. So there's your arch for you right there. But in plan view, actually, I think if you use this technique in plan view, it actually still kind of holds up fairly well. And you can use this to do shade studies. Let me just turn on the sun and sky. And you can use it to do quick shade studies of the site like that. Oh, thank you. There was let me just see if I turn it to a really low sun angle. There was I think a design at one time that used the shadow of the arch to kind of create some kind of space. So the shadow of the arch would do something like that on this plaza here. And there was a design that wanted to kind of use that shadow to actually mark that space. They never went through with that, but I don't know. If they had this tool back then, they would have been able to do that. I don't know. I just think it's kind of cool. But one of the neat things you can do with this particular drawing is if you go to the this red button up here, and I'm turning off high visual quality to speed up, and go to this little thing that looks like two overlapping squares. These are a few like basic analysis functionalities. So the one that for this particular drawing that looks cool is the terrain themes. Click on this option up here. If I just move these out of the way for a second. if you click on this plus, so a terrain themes window pops up. If you click on this green plus icon, you can make some cool elevation maps, aspect maps, or slope maps related to topography. If you click on elevation, and let's just see what it looks like as is, just click OK. We can actually use this to do some flood studies. So let's say you want to imagine what St. Louis would look like, during an amazing, great biblical flood, for instance. So I'm just going to look at this map here, and I'm going to see that the range of values here, let's say 400 something is about where the Mississippi is. So I'm going to change this color ramp to something that's just blue, and then I'm going to change the maximum value to be like 420. So that's the river, basically. But if you change it to like 422, you see it begins to fill up the site. 423, maybe let's do 430. These are unrealistic flood events, but let's say, again, biblical floods. Let's do 440, 444, 450, or 450. Oh, that looks pretty cool right there. So you can use this to actually map a cool flood condition. And I don't know if you guys have ever heard of the St. Louis project known as the Choteau Greenway. But this was a master plan that was developed a few years ago by HOK. Let's Google Choteau Greenway, where they reimagined basically that floodway that I just visualized as a new park system. So yeah, here's the plan basically. You can kind of see what they did was they used that kind of area where that floods and turned it into like a water feature just below the arch here. And it would go all the way through downtown St. Louis, all the way through the Cortex region, and basically arrive at what is currently the Grove area. And so this whole master plan was kind of inspired by this flood condition here. And I know for a fact that my boss is still trying to get this to happen for real. This cool greenway, and it's just a plan that, hopefully one day St. Louis implements. It'd be a huge plan, but probably really difficult to implement, but nonetheless, there's a little tidbit for you guys. But there you go, that's how you can start to visualize flood using this data. And you see it's cool because it wraps around the buildings as well. So you can, let's say you go full on Moses. No, it wasn't Moses. It was Noah. Sorry, my Bible knowledge is very bad. So let's say Noah is resurrected and decides that you guys have been using too much grasshopper, and he wants to wipe out humanity. This is what it might start looking like that. And so let's say, 500. All of downtown is flooded, and you gotta go into the high rises and whatever. Okay, whatever. I digress. You get the point. All right, let's get out of here. I'm gonna remove that data set. Yes. And now what I'm going to do is I'm going to add a raster. I'm going to add the DEM image. So I don't believe I gave you that, but you can download this DEM image based from the USGS resource. Let's see. Whoops. Okay, sorry for the delay. So I just added in another DEM image. This was also straight from USGS as well. It's not the highest resolution image, but that's okay. Actually, it runs pretty smoothly. So now let's add that building layer. So go to Add SHP, and I'm going to go to GIS, SHP, and it'll be Structures 2013. So in this case, let's double click on that guy, and we're going to set the type up here to a building. geolocation, as you can see, it automatically set it as MO83EF. This is MO is Missouri, NAD 83 East feet. That's what basically this means here. This for St. Louis is basically the default coordinate system. So there's a number of options here. So here there's a roof height option. If you just leave this as 33, it's going to make every single building 33 feet, which is not correct. We want this number here to actually be that value in the attribute table here. So if I go to the attribute table for the structures, open attribute table here, you see that the elevation, this is what the number we want right here. So elevation. So if you click on this little button right here, expression editor, you can basically grab feature numbers and elements from the attribute table in here. And so what I want is the elevation field, which you see right here. And I'm not gonna do anything else because that's pretty much straight up the number that we want to use. Let's look at OK. And here's the key point. These, obviously the buildings are not 400 feet tall, 500 feet tall. These are actually the elevations above sea level. So that it gives you the option right here to check this box here. So this basically takes the difference of that building, and so it only extrudes it to the elevation of the sea level. And everything else should be fine. There are some other options here that I won't get into for now because I make things get confusing. But if you click close and refresh, you'll see the results is St. Louis. And so I think this method is a lot faster and a lot more easier to do than the Grasshopper script. That's why I almost never use Grasshopper for this particular technique anymore. And as you can see, it doesn't give that much detail because it's just an extrusion, but I'll show you how you can fix that in a second for some of these buildings here. And of course the arch doesn't look right. But if something doesn't look right, all you do is just click on it and just delete it to get rid of it. So one cool thing you can do with Infraworks is you can take these building facades and you can actually give it actual geometric features. So let's say you want to take some of these residential buildings here. You can actually double click on this structures button here and you can actually give it a style. So this rule style option here, you can click on this pencil here, style chooser, you get all these facade libraries basically. And so right now it's giving the facade libraries for brick facades, but you see it has brick, concrete, marble and glass, metal, and just simple colors which you don't want to use. Let's just do a simple one like, I don't know, and they have horrible names. I have no idea what these mean. Der Certas or something. Close and refresh. And what you see is kind of cool. Let me just let that do its thing. So for contextual models, where you're not too concerned with the accuracy of the detail, this is good for quickly putting building facades on your buildings. And you can see they all look the same, which is weird. So what I actually recommend doing is not doing it in here, but just setting it custom, just setting a few of them one by one really quickly. So let's say, for instance, go back in here. Click on the pencil, and I would actually, what I'll do, I'll just erase this whole thing so there's no real style. Click close and refresh. You can click on a building, you right click on it, go to properties. You see in the stylization option here, you can just click on rule style, and you can just pick an option right there, then update that building. And it will just basically regenerate a new facade for that building. And you can see it's pretty cool. It actually has like geometry to it. So it's actually just takes that building and puts a facade on it. So if you know kind of building typologies that you're working with, you can actually use this to quickly fill up a building. And then the one last cool thing you can do is if you click on a building, you can actually give it a roof pitch. So there is this option called roof slope in the building option here. Right now it's set to 0, so it's flat, but if you give it something like 20, click update, it will just basically give it a roof pitch as well. So the point of this is not to model your buildings, because you don't want your buildings to look like this. The point of this is to establish a contextual massing for your building. So I use this technique to set up the context, but when I actually want to design my buildings, I don't use this method. Obviously, it's not for that purpose. Okay, so let's add a few more shapefile layers into this mix here. What I'll do is I'll go to the shapefile layer here, and I'm going to add the river now, so Mississippi River. So if you have a shapefile boundary of the river, you can just use that to straight up turn that into a water feature. So go to Type, Water Areas, and then set the style to just the default water right here. It's going to set the geolocation to the default UTM 8315, which is the correct one. This should work fine, so click close and refresh. So now you have the river. And if you turn on high visual quality, you can see it starts like making the reflections and all that stuff. If you have a model of the arch, you can put a model of the arch there. Okay, next is roads. This is pretty cool. So in the in here, I gave you guys a roads STL layer here. So if you have a road centerline drawing, you can basically use this line here, and what Infraworks will do is it'll take that line and it'll just generate a road on that line, and then where there's intersections, it'll just automatically model those intersections really quickly. It's pretty cool, and I'll show you how it works. It's not perfect, but for quick and dirty modeling, it's not bad. So go to Shapefile, add that roads STL layer here. Double click on that guy. I want to set the type to a road now, so roads. Geolocation automatically sets as MO83EF, which is good. Draping options, we want it to drape because I want the road to hug the terrain because it's on the ground, basically. And then rule style. So now you have all these options for types of roads that you can put in. Let's try, for instance, this street with sidewalk. Or maybe this sidewalk with lamps. And here's the thing, you can actually also edit these features as well. They can change the road width, you can change if you want to change the lamps to a different kind of lamp model. There's a lot of flexibility in terms of how you can edit this stuff. So let's just do this one. I'll do this one, street with sidewalks, and click close and refresh. So actually, if you zoom into this road layer, you see it's actually a 3D road model. And where the roads intersect, it automatically resolves the intersection and just creates, the curve there. Now, again, you see this is not perfect. Like some areas where, like for instance, where the highway is, it doesn't actually fix the highway. So this is again not a tool that you can just plug in layers and automatically looks good. It requires some effort to make it look good. But we can see like there's the start of something in terms of a city model here, and then you can turn the high visual quality to turn on the shadows and all that stuff, and do some stun studies and all that stuff. And then, for instance, maybe we want to add an actual background, an image in the background here. So the resource that I recommend you guys, if you're looking to work in St. Louis, is to use this resource called EastWest Gateway. EastWestGateway.org. This basically is kind of an organization that collects a lot of GIS data. So if you go to the data center option in the website here, data center, there's a little tab here called GIS. it gives you 2015 aerial imagery. And this is the highest resolution imagery for St. Louis you can get right now. So if you click on that option here, it'll bring up a download site. So there is this this second option right here. If you click on that, actually, sorry, go back one level. Click on the third option here. Yeah. And it gives you this download map of St. Louis. And you can basically click on any square you want and download a TIFF for that region for 2015. I already did that, so I'm just going to add a few images that I already downloaded for St. Louis in here. So I'll go to raster, and I saved that in my data folder. I believe I saved it in St. Louis ortho imagery. And it's all these, you see that this is basically the file format for all these guys. I'm just going to select all of them at the same time. Actually, I'm going to do details, type. I'm just going to select all these TIFFs. They're huge. I don't know if this is a good idea or not, but I'll give it a shot. No, it's not a good idea. Remove that. Okay, I threw in an aerial image, and what the interesting thing you see here is actually the aerial actually covers the water. And so actually the order that you put the layers in actually matters, but you can arrange the order in a way by going to this data sources table here and click on this little button here called manage the order and visibility of surface data. If you see here, basically the TIFF I put is on top of the river. So all you do is click on the river and move it up by using this little arrow here, and just click OK. And then the river will move back to the top of the top of that guy. Okay, we're almost out of time, so I will save the other Infraworks stuff for the next 2 weeks. The last thing I'll show you guys how to do is how to integrate this with your Rhino models, because you guys are going to be doing most of your work in Rhino anyway, so you're going to need to know how to bring stuff into here from your Rhino environment, so you can start modeling and designing in Rhino, then bring it into the context of your site. So first what we'll do is we have to set up a base CAD file. So what I'll do is I'll just take the road layer, for instance, and I will take the building layer and I'll export that to AutoCAD. So where's my not sure where the building layer is. Must be something with the coordinate system. I'll just take this road layer here. Data, export data, data frame. Sorry. Export to CAD. Sorry. Set the output coordinates to be same as display, and the cartography to be same as display. Click OK. Click OK. Take note of the coordinate system you're using. So this is MO83 East, right here. So this is when we bring things from Rhino into Infraworks, we want to use this coordinate system right here. So what I'll do is I'll open Rhino real quick. Okay, so once you've exported your CAD file and you brought it into Rhino, then we can do basically is you can start to model stuff in here. So let's say you want to model, I don't know, what can we model really quickly in Rhino? Some cones. I'm just simply doing this as a demo. And one thing we actually want to make sure we do is actually want to make sure these are at the correct elevation. So this is all at 0, 0, 0 right now. So ideally you'd have a contour layer that you would align these to. I think these are basically 400, it should be 400 I believe. Is that 400? Seems a little bit slow to me, but let's just see how that looks. So basically you ever designed. Oh God, this would make Sung Ho really angry. So what you do is you take take your geometry that you want to bring into Infraworks, and you export it. Did I select it? Yeah, I select it. Export selected. Make sure you have a folder or something saved somewhere. I'll just save it on my desktop for now. You want to save it as an FBX file. So Motion Builder or FBX right here. I'll call this one Horrible Architecture. You want to export your NURBS as meshes. Click OK. This gives you a meshing option. So if the higher the slider is, the more detailed the mesh will be, and the lower it is, the less detailed it will be. Generally, you want to keep this, I'd say, at least in the middle, or maybe at like 75%. And then in Infraworks, you go to the Data Sources tab and add a 3D model. And I say to my desktop, Horrible Architecture. Double click on that. You want to add it as, you can add it as one of two types, and they both have their pros and cons. Either a building, because in this case we're doing a building, or you want to add it as a road, and I'll explain why in a second. So I'm actually just going to add it as a road, which seems counterintuitive. Why would you put a building in as a road? But there's a reason for that. And then you want to set the coordinate system MO83, which is the one that we said was the coordinate system for the Rhino model. And then what you want to do is, you see in here, is everything comes in rotated incorrectly. That's because Rhino has some kind of different axis system from most Autodesk products. So whenever you bring in Rhino models, you want to flip the Y and Z in order to be oriented correctly. Once it's all set up, click close and refresh. And so this is how it looks in Infraworks, and that's how it looked like in Rhino. So you see, basically, you've established your architecture in the correct location, and then you can turn on, you know, the sun settings. You can visualize, you know, the next great monument of time. And now here's the thing. The cool thing is now you can go back into Rhino, for instance, and then you can actually make this a bit more, you know, different. Let's say you want to delete all these guys, and you want to actually do like some rectangles or something. I don't know. It's even worse. The point is, the cool thing is you just update the link once you're done with that. So then you can select these guys, export selected, just save over the last FBX file you just saved. Save, yes, replace it, yes, just use the same exact settings, and then in Infraworks all you do is just refresh that link. So right here it's a Horrible Architecture, just right click it and click on refresh. And it's just going to update automatically. So this is how I work when I'm doing work, is I set up the model first, and then I just model my ideas in Rhino, and then just keep refreshing it and just bringing it back in here quicker and quicker. And you see, it just gives, it's already almost, I'd say, close to presentation format. It has rendering quality, it has shadows and all that stuff, so you can use this to quickly visualize your ideas on a site. And as you can see, it's all on the, you can see the reflection there. That's kind of cool. But you can kind of see, this is how basically the workflow from Infraworks into other, with Rhino and that kind of stuff. So I'll show more techniques, like in terms of texturing your things, using 3ds Max to integrate stuff as we go on, and maybe doing some more custom modeling tools in the coming weeks. But in general, this is the workflow that we work with. So that's